My name is Kaiwa Jeshobe Magezi, and I'll be talking about the evolution of computers in this video, as well as the evolution of Intel x86 architecture of computers. Now, I will talk about the evolution of computers first, then I will go on to talk about the evolution of the microprocessors, the Intel x86 architecture, basically. Now, for the evolution of computers, as the word evolution, you see, this shows us a time of transition, a time of growth, a time of change for computers. And now we can see that these computers actually have transitioned from big machines for simple calculations to small devices that are actually portable and can be carried around. Devices that are manageable by their owners and are basically affordable. And we can see that computers are actually getting much better. If we look at computers like the Raspberry Pi, they're basically a change from what we initially saw computers as in the first generation, as they were very big devices occupying almost entire rooms. But now we have Raspberry Pi computers that are almost this small, the size of a chip, which is really, really, really amazing. Now, computing as a concept has actually not just been a new thing. It can be traced all the way to the early 1800s, and we see that the development of a computer has actually taken time and research, as people had ideas and they would build on those ideas, and then eventually we came up with the machine known as a computer. Now, in the 1800s, we can see devices that were used for calculating, basically, like the abacus. We can see the Napier's bones. We can see Leibniz calculator, and these were among the many devices that showed the growth of computing over the ages, even before we got machines known as computers. Now, to accurately trace the evolution of computers, we can start from the 1930s, where we see the first calculating machine known to man, which was created by Konrad Zuse in Berlin, and this was named the Z1. Now, the Z1 had developments like the Z2, the Z3, and the Z4, and this was the first programmable and digital computer known. Sadly, this computer was destroyed. Its earliest models were destroyed in the World War II. As you heard, he was a German, and basically Germany was the hotspot for the war, for the Second World War. And for us now to understand the first generation of computers, we have to look, back into the 1940s, and this is where we see computers occupying whole rooms, as they were humongous, and this was in the period of 1940 to 1956. And we see computers like the ENIAC, we see computers like the UNIVAC, both made by John Mauchly. The ENIAC was made for battle, basically, for ballistic analytics, and this was used in World War II. The UNIVAC, however, was a much more commercial creation, because it was made for business and government applications. And these were both first generation computers. Now, a characteristic we can draw from these computers was actually the use of vacuum tubes and punch cards for input and output. Now, these vacuum tubes were central to the working of a computer in the first generation. But however, they had some disadvantages, obviously, and these disadvantages include they used to consume a lot of power, they were very large, they were expensive, they were heavy, and they were slow. Now, for a computer, we obviously want to improve the speed, we want to improve the storage capacity, we want to improve the portability, and this is a sign of evolution. Basically, we want to make them better adapted to our community and for our use, to make them as effective as possible. Now, for vacuum tubes, this seemed almost impossible because they were very large, and so we had to look for something that was actually smaller and would consume less energy, because energy efficiency is central to the development of computers. And with research, obviously, we made by scientists, we were able to move from vacuum tubes and on to transistors. Now, this marked the second generation of computers, and this spanned from 1956 all the way to 1963. Now, shortly before 1956, in 1953, there was the creation of a prototype named Manchester TC, and this was the first prototype created using transistors. Now, this generation of computers was easier to program, and because it was easier to program, there was actually the birth of a new computer language which was named COBOL. The first generation of computers was not as easy to program, so there were problems with that, but the transistors sort of provided a better platform for programming. Now, other computers that were that can be put in the bracket of the second generation include the IBM 701, and in 1960 IBM also went on to make mainframes that used transistors, and this was actually another step toward development in terms of computing. Transistors were actually much smaller, as I said, faster, and they were cheaper compared to the vacuum tubes. And at this generation, we see computers actually having necessary components like storage capacity, we see printers, we see operating systems. Now on to the third generation. The third generation was characterized by integrated circuits, which can also be called ICs. And this spanned from 1964 to 1971. Now these ICs are also popularly known as processor chips. They are smaller, they are faster, and they offer more storage capacity compared to the transistors. And these computers actually also had an OS, which made them able to run different programs at the same time. Some of the computers that can be thrown into this bracket are IBM 360 series and the IBM 370 series. Now, we can head over to the fourth generation. The fourth generation of computers actually does not differ so much from the third, as it is only an improvement in the use of processor chips. Now, for the fourth generation, the characteristic here is the use of microprocessor chips. And so you may ask, what are microprocessor chips? These are very large scale ICs, integrated circuits. They are much better than the original integrated circuits in the third generation. And here we see that all CPU components are actually installed onto a single chip. This makes it much more smaller. The computer is much more smaller. It makes it faster, more efficient, and generally just good and portable for use. And this basically birthed the PCs that we have today, because we see companies like Apple Macintosh coming into play. We see the IBM PCs, and these made computers able to come into people's homes, as we see the first laptops, we see mobile phones, smartphones basically, and this is all thanks to the microprocessor chips. So you may ask again, how can we make computers even better? Now, this sort of question unlocks the mystery of the fifth generation of computers, where we need faster, smaller, larger storage capacity, and ability to solve more complex problems. Now, this basically leads us to supercomputers. So, what are supercomputers? Supercomputers are basically the best type of computers around right now, and their fundamental characteristic is the use of AI, artificial intelligence. Now, an example of such computers as this is the Cray 1 series in the US and the Param 8000, an Indian computer. Now, AI is aimed at computers being able to solve problems in a way that humans would, and that is the goal. That is the goal of the future, for computers to be able to take decisions, to be able to make life-changing decisions, to help people in life, to revolutionize basically the marketplace, and to make everything different and much better. Now that covers the evolution of computers, and we shall be moving on to the Intel times 86 architecture. The Intel x86 architecture. Now, to understand this, we need to also understand what computer architecture is. Computer architecture is the organization of the components which make up a computer system and the meaning of the operations which guide its function. It defines what is seen on the machine interface, which is targeted by programming languages and their compilers. Now, for microprocessors or processors to be grouped under the same type of architecture, it means they need to share in certain things. And for this case, like the organization of the components which make up the computer system, and also the meaning of the operations which guide the function of the computer. Another thing that these microprocessors may have to share in is the machine interface. So when we talk about the Intel x86 architecture, we know that the microprocessors that were included in this architecture actually shared in these things, that the machine interface should have been similar or the same. They should have had the same type of organization. They should have had the same meaning of the operations which guide the function of the microprocessors in these computers. And so this gives us an understanding of what the Intel x86 architecture encompasses. And so why you may ask, why Intel x86? Well, the reason for the name x86 is that the microprocessors that were of this series or of this architecture, they came with the number 86 at the end. And so the X just took the position for the version, where we have the first one was just 86, the second one was 286, third one was 386, and the fourth one was 486. Now, this architecture actually evolved over a couple of years, and we see a couple of drastic and if not dramatic changes. Because if we look at the 8086, which was the first version of this Intel x86 architecture, we see a total of about 29,000 transistors. And if we go all the way to the last version, the Intel Core 2 microprocessor, the quad core, it has about 820 million transistors on one single chip. And so these are among the developments that came along with this architecture, with its development and with its transformation. These are some of the things that were taken into consideration to make them work better, to make them faster in processing, to make them have better data path widths, to make them have better addressable memories. We see just growth in these spheres. Now, the following are some of the highlights of the evolution of this particular architecture. Now, before this architecture, we had the 8080 microprocessor, and this was the first general purpose microprocessor. It was an 8-bit machine with 8-bit data path to memory. Good for its time. It was used in the first PC. But right after this, we have the very first member of our x86 Intel architecture, and this is the 8086 version of a microprocessor, and this is a 16-bit machine, stronger than the previous one because the previous one had 8 bits. And now this one also came with a 16-bit data path and larger registers, along with instruction cache or queue that prefetches some instructions before execution. This was the first appearance of the x86 architecture. It had an addressable memory of about 1 megabyte. It had a real mode. The cache here was the level 1 cache. Cache is basically a temporary memory where the computer can pick the stored information or data for future use in case it is required. Again, the computer won't have to go all the way to the main memory, but it can now just go to the cache memory, get that information again, and then reproduce it as an output. So the cache actually reduced on the time taken by the computer to go to the memory, pick the information required, and output it. And so after this we have the 8286 version, and this one had an addressable memory of 16 megabytes. It had two modes, the real and the first generation 16-bit mode. It had a 16-bit data transfer width, 16-bit programming model. It had 16 bits general purpose registers and a 16-bit addressing. After this one comes the 8386 version, and this one was a 32-bit machine, another development from the 16 bits of the previous one, and this was the third version of this x86 architecture. Now this one could compete with the complexity and power of microcomputers and mainframes introduced just years earlier, and this was the first processor to support multitasking with 32-bit protected mode. Also implemented the concept of paging. It permitted 32-bit virtual memory address to be translated to 32-bit physical memory address. It had an addressable memory of 4 gigabytes and data transfer width of 32 bits. After this came the 8486, which was the fourth version of the x86 architecture. And here we see the introduction of cache technology, instruction pipelining. It contained write protect features and offered a built-in math coprocessor that offloaded complex math operations from the CPU. This was basically the close of the chapter with the number 86 at the end of these microprocessors, and now we started a new chapter with the Pentiums. And as you can see, this was the character of these were some of the characteristics of the Pentium. Superscalar techniques introduced, multiple instructions started executing in parallel. It had a page size extension. And after the Pentium, we had the Pentium Pro, which also had its own developments, which included a level 2 cache. It included more pipelining stages and a 36-bit physical memory address. After that came the Pentium 2, and the Pentium 2 was basically it basically introduced the MMX technology, which is just multimedia extension. And after the Pentium 2 came the Pentium 3, which had its own characteristics, some of which included, supporting 3D graphics, the maximum CPU clock rate of 1.4 gigahertz, and contained about 40 new instructions. After that, we had the Pentium 4, which implemented third generation address translation, 48-bit physical memory address, among other things. After the Pentiums came the Core microprocessor, and the Core microprocessor was actually a dual-core microprocessor because it implemented the use of two processors in a single chip, and visualizing technology was also added. After the Core came Core 2 microprocessor, and this one was a quad core, which basically just means 4 processors this time in a single chip, and this one went all the way up to 64 bits, which was basically also a development. Summary of the developments in particular to the x86 family of Intel processors. And as you can see, the 8086 had a 16-bit data bus, 20-bit address bus, 5 to 10 megahertz operating speed, memory capacity of about 1 megabyte. It was introduced in 1978. Go to the 8286, we see a 16-bit data bus, a 24-bit address bus. We see an operating speed of about 6 to 20 megahertz, memory capacity of 16 MB, and introduced in 1982. We see the 8386, and this one characterized by 32-bit data bus, 32-bit address bus, a 16 to 33 operating speed in megahertz, and a memory capacity of about 4 GB. It was introduced in 1985. The 8486, the last version with the 86 at the end, had a 32-bit data bus, a 32-bit address bus, an operating speed of 25 to 50 megahertz, a memory capacity of 4 GB, and was introduced in 1989. If we look at the Pentium, the Pentium had a data bus that was 64 bits wide. 64 bits wide. It had an address bus of 32 bits, an operating speed of 50 to 100 megahertz, and a memory capacity of 4 GB. It was introduced in 1993. Now we see a gradual growth in the bus width of these processors, meaning that they are able to transfer more information, more instructions, and the speed is also gradually growing. And this is basically the evolution. We see the memory capacity also changing, becoming bigger and bigger from 1 MB to 4 GB, and this is all over a certain amount of time. And that is the evolution of the Intel x86 architecture. Thank you for listening. Hope this has been a very useful video. Thank you.